Okay, let's see how to multiply these things. Let's start with multiplying. All right, so if I wanted to multiply two, and you might have done this before in like an algebra class. If I wanted to multiply two complex numbers that look like this is the process, right? And it's real messy. So you could find the imaginary value. You have to FOIL. That's how we got this step. And then you have to figure out the angle, which could be real complicated as well if you wanted to put it in to trig form. Okay, and that looks messy, right? I don't want to go through that completely, but I want to show you the easier way to do it. All right, so if I want to multiply these two numbers, z1 and z2. So if I can find the trig form, I'll show you how it works. Okay, so first I got to find the trig form of this. So let's see, what's the best way to do this? I'm going to draw a quick picture and see if I can rely on my trig knowledge. 2 root 3 plus 2i. So that's 2 root 3. And then I go up 2, and there's my triangle. You recognize that? You should. This is 30 degrees. Right? And then this would have to be 4. You don't even have to do the Pythagorean theorem if you can recognize that stuff. So this is equal to 4 times the cosine of pi over 6 plus I sine pi over 6. Okay, how about this one? This should be in quadrant 1 as well. 3 root 2. So I go 3 root 2 in the x direction. And then I go up 3 root 2. Okay, we should all recognize this triangle. These are the same sides. This has to be 45 degrees or pi over 4. And what would the hypotenuse be? Like I said, Pythagorean theorem if you want. But remember, it's always root 2 times one of the legs. So I would say mod z here has to be root 2 times the 3 root 2. Or Pythagorean theorem, either way, root 2 times root 2 is 2. So this has to be 6. Okay, so this guy is 6 cosine pi over 4 plus I sine pi over 4. All right, now here's the rule for multiplying. Let me give you the formula. To multiply two complex numbers, you have z1 that will be r1 or modulus z1. I'm calling, we use these two interchangeably, okay, times the cosine of theta 1 plus I sine theta 1. z2 then in generic form would be r2 cosine theta 2 plus I sine theta 2. And when I multiply this together, z1 times z2, here's your formula. And I'll show you why this works. You just multiply the two hypotenuses, or two moduli, and then you just get to add the angles. Theta 1 plus theta 2 plus I sine, add the two angles. Okay, I know that looks messy, but that's actually really easy. That's a formula for you. Let me show you how easy it is to do this problem. All I got to do is multiply these two numbers. So for this particular problem, z1 times z2 is 4 times 6, 24. Cosine of pi over 6 plus pi over 4. If you want to do degrees, I'll let you do that because it's a lot easier to add degrees. But we can add radians as well. Let's just keep it at radians. It's pi over 6 plus pi over 4. And that's, if I want to get a common denominator here, that's 2 pi over 6. I'm sorry, 2 pi over 12 is the common denominator would be 12. And pi over 4 would be 3 pi over 12, right? I multiply this by 2 times 2 times 2. 2 pi over 12 times 3 times 3. So that's 5 pi over 12. And that's it. That is my answer. And if you're not sure if that works, here's my work over here, or the worked out. R was 24 with doing all that. Look at all that work they had to do to get that way. And then the angle is 75. And 5 pi over 12, you can check that. That is indeed 75 degrees. Okay. So how do I multiply two complex numbers in trig form, I use this formula. You multiply the two moduli, add the two angles. That's it. It's that easy. So where does the work come in? Well, if you're given your two complex numbers in rectangular form, you have to convert them. And that doesn't take long if you know your trig. So we did that, convert, convert. And once we converted, using this formula is easy. So division then is going to be very similar. Okay, here's what you don't want to do. Here's how the dividing would work if you didn't have trig form. It's that messy. We don't want to do that. So here's the formula here is given to you. It's typed. And you might guess that if to multiply I multiplied the two moduli. When I'm dividing, I divide them. And then instead of adding the angles, I subtract them. Okay, that's your formula. That's formula 2. So let's do one. Again, this is just to show you why we don't want to do it this way. You can ignore that if you want. There's all the work that I would have to do. In this case, the conversions are done for you, or we already did them. This time, let's go angles. Let's leave it in degrees rather. Okay, so it's the same two numbers. I'm just dividing them. Same two numbers that were given for multiplication. Okay, so Z1 divided by Z2, Z1 is this number divided by that number times the cosine of that minus that. And you, like I said, you can do this in degrees or radians. In this case, we're just choosing to do degrees. So I should have these marked everywhere as degrees. And that's it. If I divide Z1 divided by Z2, I just get 3/2 times the cosine of 15 degrees plus I times the sine of 15 degrees. And that's it. That's my answer in trig form. Now, I might have to put this back in rectangular form, which I could do by just taking the cosine sine of 15. Okay, let's see. Do I have time? I know that's just one example, but it's pretty straightforward. If you can convert and you can use the formulas I'm giving you here, that's one formula. There's my other formula. Sorry, that's a little messy. And here's my next one. This is great. This is a great result in math called DeMoivre's theorem, and it's just remember, raising to power is just multiplying multiple times. So if we added two angles, if you want to do that multiple times, then you'd use multiplication. Okay, so if I want to raise a complex number to a power, I take the modulus, raise it to that power, and I simply just multiply the angle by the power I'm raising to. That's it. So let's do one. Let's say I gave you a number. So, oh yeah. I started the other two conversations with why don't we leave it in rectangular form? Well, here's why. If I want to raise a complex number to the n power, that's that same factor that many times. And that's really complicated. Okay, really complicated. And then not only that, we're going to have i's to large powers, which I'd have to deal with that as well. It's much easier in complex form, or trig form rather. Okay, so let's say I gave you a number that's this is as easy as it gets. If you don't even have to convert, I say here's z in trig form, 5 times the cosine 20 plus I sine 20, raised to the third power. All you got to do is raise that to the third, multiply that by 3, and you're done. And then possibly you could convert this back to standard form if you want to, knowing that the cosine of 60 is a half. And the sine of 60, of course, is root 3 over 2, ... We can always go back to regular form. Okay, that's it. Let's do one where we have to convert. All right, find z to the 6. One thing we'll do is if our angle we multiply by big numbers, it might go over 2 pi. So it got cut off a little bit. Leave answer in complex form with argument between 0 and 2 pi. Okay, so what are the steps here? Convert, and then use DeMoivre's theorem. my third formula. So here's how I convert. Can you convert this without doing anything? Can you convert that in your head? I say, oh, I go back 5 and then up 5. That's quadrant 2. That's a 45, 45, 90 triangle. And then the hypotenuse should just be 5 times root 2 because I'm so familiar with that. So I should have 5 root 2 times the cosine of 135 degrees, I sine 135 degrees. If you can't do it in your head, that's okay. Just draw a quick picture. Back 5, up 5. Back 5, up 5. And then if you want Pythagorean theorem, right, you could find R, which we're also calling mod Z. Either one of those is okay. You could do Pythagorean theorem. I mean, I know this is 5 root 2 because I know the triangle. But if you just forgot or something, you want to be sure, prove Pythagorean theorem. Square root of 50 breaks up as root 25 times root 2, and then I get 5 root 2 that way. Okay, what about the angle? Well, we could do some tangent, a tangent function to get the angle, but it's much better if you just know it. This is 45 degrees, so this is 135. Or this is pi over 4, so this is 3 pi over 4. Okay, in this case, the problem indicates that we want to use radians, angle between 0 and 2 pi. All right, so let's do it. So the same value, the same angle, or the same complex number rather, is 5 root 2 times the cosine of 3 pi over 4 plus I sine 3 pi over 4. And then if I want to raise that to the 6th power, oh boy, I got to raise this to the 6th power. That's not very nice of me. That's a big number. 5 to the 6th. I need my calculator for that. Root 2 to the 6th. Remember how to raise a product to a power. You raise that to the power and that to the power. At least it'll get rid of my root, so that'll be nice. And then how about this guy? I just multiply this by 6. That's easy. Kind of redundant work here. Whatever you're doing in the parentheses is the same both times. So you really only have to do it once. Take 2 into both of those, right? 2, 3. So my angle then should be what? 9 pi over 2? And this, oh geez, I don't know. Where's my calculator? I'm just going to leave that. You would just plug that in your calculator. I don't know what 5 to the 6 is. This would be, root 2 to the 6 is what, 2 to the 3rd. So that's 8. So that's the best I can do in my head. 5 to the 6 times 8, whatever that is. And then, now I got to be careful because for these problems, you're going to get large angles, right? Because of the nature of the formula. When you do like 6 times an angle, you might be too big, right? And what we learned, as long as you're in the same place, it's the same cosine value. So 9 pi over 2, what do? Is you just subtract 2 pi's, right? You just subtract revolutions till you're between 0 and 2 pi. So I would just, keep subtracting 2 pi. I'm not sure how many times I have to do it, but until you land between 0 and 2 pi. Or you could do it graphically. 9 pi over 2, this would be, let's see, count by pi over 2. So 1 pi over 2, 2, 3, 4 pi over 2, 5, 6, 7, 8, 9. That's 9 pi over 2. You land in the same place, and I'd get the same answer if I subtracted 2 revolutions as pi over 2. So my final answer is, I have my tablet in tablet form, so it's kind of difficult to go to my browser to raise 5 to the 6th. So I'm just going to leave it like that, almost complete. But I definitely have to adjust the angle. And my final answer using DeMoivre's theorem is this number times the cosine of pi over 2 plus I sine pi over 2. This would be easy to convert to rectangular form if I had to, because the cosine of pi over 2 is 1.